Okay, I wanted to talk about 517 sort of conceptually. Of course, the calculation's pretty straightforward, but here's the basic idea from this one, right? So, first thing is writing a moment equation. Okay, so you write a moment equation, and what you're going to recognize here is there's a reaction here essentially, and a reaction at B and a reaction at A, pushing straight up. Um, So what you're going to recognize here is that if we do like the moment about point B, what we're going to have is we're going to have a moment or a force essentially, um, or a reaction acting at point A straight up, which is this one here. Okay. And whether or not you write it as a negative or a positive, in this case, what we're saying is it's acting straight up, so it would cause clockwise rotation about point B. Okay. The second one is this, and this is how this one is actually uh, set up. Okay, so what we have is we have some distance from this point to here. Okay, now what we're looking for is how far away this g is in terms of as the road as the angle increased, g would come more and more over here. We're looking for how far away g is from b. Okay, and this will determine whether or not the distance, whether or not it causes clockwise or counterclockwise rotation. So if it's over here, let's say it's up here somewhere, so the angle's pretty large. So let's say G is up over here. Um, what's going to happen here is that would cause counterclockwise rotation about that point. Okay. Now, as this goes down further and further, as you're going down further and further, so the angle is decreasing further and further, what you're finding is G is going off to the right more and more. So how far? Well, this determines this is the actual distance from in the x component of the distance, this whole term here. Uh, I'm sorry, not the whole term, but this term. This is actually the x distance of the g from this point. The 3 is essentially from here to B. So what you're actually looking for is the point at which the distance of G is essentially right over B. Okay. Once G goes beyond B, in this case, at any amount, so once this actually turns out to be 3. Once G gets anywhere beyond beyond B, to the right of B, what's going to happen? It's going to cause rotation about point B. Okay. And then it's just going to rotate off. And that's all this term is saying. So essentially, it says that when it's at point B, when the moment's at point B, which means this essentially equals 3, so there's no reaction at A, and this term here equals 3, this comes out to be 0, and then we can solve for this whole thing becomes 0, and then we could just rearrange this equation and solve for this, okay? Solve for the magnitude, because of course we can just divide out the W. And that's essentially it. So what you're really looking for conceptually is the point at which G is essentially to the right of B. Okay, and this is how the author chose to actually set up this particular equation. And that's it essentially. So it's not the math is not too bad. It's more like thinking about it conceptually, how you would actually go about solving this.